Today we're going to be solving absolute value inequalities. Now if you remember last class, we solved absolute value equations. Now the only difference between these two is last class we solved, for example, 2x minus 4 equals 7, we'll say. This is an absolute value equation because it has an equal sign. Today, we're going to take that equal sign and we're going to turn it into an inequality symbol. Now, as for solving, not much is different from last class. We're still having to account for both the positive and negative version of this absolute value, but we're going to have a few more steps included in this process. So now if we look at number 1, we have the absolute value isolated. The absolute value is all by itself. So now is when, last class, we would take this problem and we would split it into the positive and negative versions. The positive side means we're leaving this as a positive 32, but the negative means we're taking that 32 and making it a negative 32 instead. So let's go ahead and try it. Right now I have absolute value of 4x is less than 32. When I go ahead and split it, I can now get rid of the absolute value. So I have 4x is less than 32. When I'm creating my negative, I do the same thing at first. I write down 4x's first, but then I change that 32 into a negative 32, and we have to flip the inequality sign. So it's no longer going to be a less than symbol. We now have to flip it to be a greater than symbol. We need to flip the sign on the negative side. All right, and that'll happen every time we're doing the negative version of the absolute value. So let's go ahead and solve each one of these. Over here on our positive side, I have 4x is less than 32. To get the x by itself, right now it's 4 times x. It's multiplication between the 4 and the x. So I divide both sides by 4. The 4 divided by 4 will cancel, leaving me with just x on the left is less than 32 divided by 4 is 8. So this reads x is less than 8. And I have solved for x. I do the same thing with the negative. I need to divide both sides by 4 to get the 4 off the x. And I'm left with x is greater than negative 32 divided by 4 is a negative 8. So here I have two solutions, or two inequalities I should say. X is less than 8 and x is greater than negative 8. Because we're dealing with inequalities, when we're writing these solutions, the solution set, because it's going to be a range of possibilities because we're dealing with inequalities, we're going to have to graph these on a number line. Now all you have to do is place the two values that you found, the 8 and the negative 8, on your number line in the correct order. So negative 8 is less than 8, so I'm going to put it more towards the left. Let me change my color here. So I have a negative 8. And then my other solution of 8 needs to go somewhere to the right of that negative 8. Now each one of these symbols is either a less than or greater than symbol. It is not an equal to. So on these values, I'm going to put an open dot. If it had been less than or equal to or greater than or equal to, I would have put a closed dot. Now before we shade, which we could based on the inequalities we found, x is less than 8, so I would shade to the left of 8, and x is greater than negative 8, I would shade bigger than negative 8. Before I do any shading, I want to check to make sure that the inequality signs that I found in my problem are the correct inequality signs. It's very, very easy for your inequality signs to get flipped around, for you to get confused in these solving absolute value inequality problems. So what we're going to do is we're going to check our solutions. Now, if you look at this number line, notice that there are actually 3 separate sections. There's this first section on the left, first section. There's the second section in the middle, and the third section all the way on the right. We could either shade between the -8 and the 8, that's in the second section, or we could shade in both the first section and third section. Or in other words, we could either shade between, inside, or outside. So this is the area, the second section is the inside. I like to, whoops, oh gosh, inside. I like to call it the inside section. And the first and third I like to call the outsides. We need to pick a random number outside of our 2 values and check that value. And then we also need to pick a random number inside of our values, our boundary points they're called. 8 and -8 are our boundary points. Inside of our boundary points and check that value. So I think I'm going to come over here and choose to check -10. See how that's outside of our -8 and 8 boundary points. Now to check a solution, what you do is you look at the original inequality. Absolute value of 4x is less than 32. And we're going to substitute the random number we chose on the outside for x. Again, we substitute into the original. Plug into original inequality. So I'm going to take -10. I'm going to substitute it for what was x in our original. So then I have 4 times -10, -40, is less than 32. And the absolute value of -40 is 40. So we have to ask ourselves, is this true? Is 40 less than 32? It is not. So we do not shade on the outsides. You only need to check one of the outsides, because if I shade one outside, I must shade the other. So then, I need to double check that I am shading on the inside. Now the reason I now need to check the inside is because you could end up with a problem that has no solutions, meaning both of your checks don't work out. So we do need to check the inside as well. Now I'm going to pick an easy number. You always want to pick the easiest ones. I'm going to pick 0. So I'm going to take my original equation, my original inequality, I should say. 4, absolute value of 4 is less than 32. Again, I'm plugging it into the original, and I am substituting 0 in this time. 4 times 0 is 0. The absolute value of 0 is less than 32. Whoops. And the absolute value of 0 is 0. So we ask ourselves, is 0 less than 32? It is. It's a check. So that means I do shade between my 2 boundary points. So my final answer is an inequality. My solution set, I have shaded between -8 and 8. So I write those down, -8 and 8. My solutions, my x's, are between those 2 values. So I just write an X between -8 and 8, write the less than symbol, and I'm done. That's my solution. So let me try another one. Let's get a little harder. Let's do this one right here. Number 3. So just like when we were solving absolute value equations, before we can do the split, we have to get the absolute value all by itself. Right now, the absolute value is not all by itself. Right now, the absolute value has a -7 on the same side. So the first thing I'm going to do is add 7 to both sides. So I have absolute value of 9x minus 8 is greater than or equal to 66 plus 7 gives us, whoa, what am I doing? Sorry guys, 73. So now that I have my absolute value all by itself, now is when I can split it into the positive and negative. So I have, now is when I get rid of the absolute value, 9x minus 8 is greater than or equal to a positive 73. And then I have 9x minus 8. Remember, on the negative side, I flipped the sign. So it was originally greater than or equal to, now less than or equal to, negative 73. Again, remember to flip the sign. So now let's solve. Need to get the x all by itself on the positive side. So first here I have a 9x, that's multiplication, minus 8. It's easiest to first do the opposite operation of -8 and add 8 to both sides. So I have 9x is greater than or equal to 81. Then, to get the 9 off of the x, that's multiplication. Opposite operation means we divide both sides by 9. And I have x is greater than or equal to 81 divided by 9 is 9. So that's my first boundary point, it's called. Then I do the exact same process over here on the negatives. I add 8. And I have 9x is less than or equal to negative 73 plus 8 is a 65. Oh, it's a negative though. Negative 73 plus 8 is a negative 65. So then I divide both sides by 9. And I have x is less than or equal to negative 65/9. Now, normally you'd get nicer numbers than this. 65/9 cannot be simplified, so I leave it as negative 65/9. It's about 7.33 if I do it in my calculator, I think, if I remember correctly. Normally we would get much nicer numbers. So now that I found my two boundary points, I go ahead and place them on my number line. 9 is much bigger than negative 65/9, so I'm going to go ahead and put 9 to the right and negative 65/9 on the left. And these are greater than or equal to and less than or equal to symbols, meaning on my boundary points I'm going to have closed circles, closed dots. So now we need to check. We need to check for where I should be shading, on the inside or on the outside. So first I'm going to check for my outside. I'm going to pick the easiest number on the outside of my two boundary points. So I think I'm going to pick And it doesn't really matter. I think this time I'll pick 10, a positive 10. So I'm checking 10, and remember I'm plugging it into my original. So my original is the absolute value of 9x minus 8 minus 7 is greater than or equal to 66. So I have the absolute value of 9 times x, what was the rest? Minus 8, and the absolute value minus 7 is greater than or equal to 66. And I'm going to substitute some random number outside of my boundary point. So I'm going to substitute 10. Again, you can choose any number you want as long as it's on the outside of my 2 points. 9 times 10 is 90. Minus 8 gives us 82. Then the absolute value of 82 is 82. Minus 7 gives us 75. And we have to ask ourselves, is this inequality true? Is 75 greater than or equal to 66? And it is. Whoops. So that means I will be shading it outside. And if I shade one way outside, I have to shade the other way outside. But we still do need to check if I need to shade on the inside. And we need to do this because some solutions could give us all real numbers. Some solutions could give us all real numbers, meaning I would shade everywhere. So I'm going to check on the inside. I'm going to choose the easiest number between the 2 boundary points, which is 0. So instead of plugging in 10, I'm going to plug in 0 to my original inequality. 9 times 0 is 0. So I'm left with just a negative 8 on the inside. Negative 8, the absolute value of negative 8 is 8. Minus 7 is 1. I have to ask, is 1 greater than or equal to 66? And it is not. So I should not be shading on the inside. So my final answer are all the x values smaller than, less than negative 65/9, and also all the x values bigger than 9. So I'm going to have 2 inequalities for my solution sets here. One where x is less than negative 65/9, comma, and one where x is bigger than. Oh, but this was a less than or equal to symbol, so it does need to be x is less than or equal to negative 65/9, and x is bigger than or equal to 9. And that is my solution set. And I'm done. Okay, let me do one more with you. Let's look at this number 4. Again, we start off the same way. We need to isolate the absolute value. Right now there's a 4 with it and a negative 2. So the first thing I'm going to do to isolate my absolute value is subtract the 4 over. I'm not going to deal with the negative 2 yet because that negative 2 is being multiplied by the absolute value. So I'm first going to do the easy part, adding and subtracting. I'm going to subtract 4 over. So I'm left with negative 2, absolute value of 6 minus 6x is greater than negative 84. Now that negative 2 is being multiplied, opposite operation tells us we divide by negative 2 to get it off of our absolute value. And negative 84 divided by negative 2 gives us a positive 42. So now I have my absolute value all by itself on one side. Now to solve, I need to split. Split between the positive and negative. So I'm going to have 6 minus 6x is greater than a positive 42, and 6 minus 6x, we flip the sign, is less than a negative 42. And I need to solve both of these for x. First thing I'm going to do on the positive side of our equation is I'm going to subtract 6 over. And I get negative 6x is greater than 42 minus 6 gives us 36. And I will divide by negative 6 to get the negative 6 off of the x, because right now they're being multiplied. An opposite operation tells us to divide. Ooh, don't know what, oh my goodness. So I'm left with x is greater than, oh, now, notice here, we are dividing by a negative. Whenever we divide by a negative, the inequality sign flips. So it was a greater than symbol, now it becomes a less than symbol. And 36 divided by negative 6 gives us negative 6. So x is less than negative 6 we should end up with. We do the same thing on the right, the same thing on the negative side. We're going to subtract 6 over, and we have negative 6x is less than negative 42 minus 6 gives us negative 48. And we're dividing by negative 6. Oh, again, we're dividing by a negative. So I have x is greater than, see my inequality sign flipped again. Let me do that in orange. My inequality sign flipped again because I divided by a negative. Whenever you divide by a negative, your inequality sign flips. So we have x is greater than negative 48 divided by negative 6 gives us a positive 8. So I have my two boundary points, negative 6 and 8. I'm going to go ahead and put those on my number line. Negative 6 is more, it's less than 8, so I'm going to put negative 6 over here to the left and 8 on the right. And they are just less than and greater than symbols, not equal to. So I'm going to put open dots on those two boundary points. And as always, I need to check my inside and outside to know where to shade. So I'm going to choose, let's see, I guess this time I'll choose a negative 10. Again, it doesn't matter as long as it's somewhere on the outside of your two boundary points. And we're going to plug this into the original, which is 4 minus 2 absolute value 6 minus 6 times our new x is greater than negative 80. So we're checking for negative 10. Instead of an x, I'm going to put negative 10. Whoops, I meant that was supposed to be pink. There we go. Now, negative 6 times negative 10 is a positive 60. So that we have this. So we have 6 plus 60, which is 66. Then we take the absolute value of 66, and it just gives us 66, times 2 is, whoops, turn on, 132. So we have 4 minus 132. 4 minus 132. Whoops. And we get negative 128 is greater than or equal to negative 80. This is not true. Even though it's a bigger number, negative 128 is much smaller because it's more negative. It's much smaller than negative 80. So this does not check out. This is not true. We do not shade on the outside. So now let's check the inside. I'm going to check the easiest number on the inside, which is 0. So I'm going to plug 0 into our original. Six minus 6 times 0. 6 times 0 is 0. So on the inside there, I'm just left with a 6. Whoops, I need that 2 to be there. 2 absolute value of 6. Negative 2 times the absolute value of 6. Absolute value of 6 is 6. So negative 2 times 6 is 12. And 4 minus 12 is negative 8. Oh, how did I drop my... Over here I had less than or equal to. I don't know how I came up with that. This eraser is not sensitive enough. There we go. So then over here, negative 8 is greater than negative 80. This is true. Even though it's a smaller number, 8 is smaller than 80, negative 8 is less negative than negative 80, making it bigger than negative 80. So I am shading on the inside between my two boundary points. So the way that I write this is I write my two boundary points, the X goes between them, and I write my inequality symbols. And that is my solution set, and I'm done. So now you guys, your homework and what you should do for the rest of the class is 5, 6, 7, and 8.